Today I'm going to talk through how to represent molecules in different ways. So you can use the molecular formula, which just tells you the atoms present. So C3H6 has 3 carbons and 6 hydrogens, but it doesn't tell you how to draw that molecule. With more complicated alkenes, molecules where you don't even know which among series they fit into, it can become very important to know the structure as well. That's just the molecular formula. So when the molecular formula is not enough, you can use some form of displayed formula or skeletal formula to show the structure. So both of these are different ways of representing the structure of the molecule. And for that reason, they can both be called structural formula. So both of these kind of fit into the category of structural formula. Displayed means it shows literally all bonds present. So if it's displayed, you need to show all bonds. If it's skeletal, you don't show the carbons. So in a skeletal formula, you do not show the carbons. So you do show the backbone of the molecule, which is a carbon chain, but you don't have to draw in all the individual C's to represent carbons. It's just assumed that all bends and ends are carbons. So if the molecule bends, there should be a carbon there, and at the end of the molecule, there should be a carbon. Ends and ends. So as for the hydrogens, we know that all carbons need 4 bonds. So we just add in whatever number of hydrogens are actually needed to make sure all of those carbons have the bonds that they need. So here, I would break this up into 3 steps really. To convert from skeletal formula to displayed formula, I just draw on the skeletal formula. There's my carbon, is at the bend, and the 2 ends. Okay, so I've got 3 carbons, and we'll draw my 3 carbons in here. And you can see between that first and second carbon, it's actually a double bond. So I'm going to add in a double bond, so that counts for 2. And then to add in my hydrogens, think, okay, this carbon needs 4 bonds, so that needs 2 more. I draw in those 2 hydrogens. The middle carbon has 3 bonds, so it just needs 1 more. And the carbon at the end needs 3 because it only has 1 bond from the main carbon chain. So that's your first one. That is called propane. Prop because it has 3 carbons, and ene because it is an alkene. Means it has a double bond. All right, so that's your very first skeletal formula converted to a displayed formula. Next one, we have to get both the molecular formula and the skeletal formula. So molecular formula, there's 3 different elements: carbons, hydrogens, and oxygens. And then you just add below the number of each that there are. Remember, you can pause this video anytime to try things yourself before watching the rest. So there's 2 carbons there, so that's C2. And 1, 2, 3, 4, 5, 6 hydrogens and 1 oxygen. So it's C2H6O. Sometimes, just to let people know it's an alcohol, you'll see this written as C2H5OH. So obviously there's still 6 hydrogens, but they just put the OH at the end with the oxygen, so you know that there is an alcohol group there, that is an alcohol. Okay, so to draw that as a displayed formula, firstly we'll do our carbon chain. So carbon chain, I'll stick to blue. There's only 2 carbons, so draw a straight line. One end is the first carbon, the other end is the second carbon. The 3 hydrogens here are assumed. They're assumed to be there because there's an end. If you didn't draw anything there, we would assume the other end also had 3 carbons, or 3 hydrogens, sorry. We are going to have to draw the OH in there. So We're going to draw another line. This time, instead of leaving it blank, we're going to write OH, and that lets us know that this isn't a third carbon at the end there. There is an oxygen, so it's an oxygen that's at the end. If you hadn't drawn that OH, we would have assumed that was another carbon. So that's it. That is ethanol represented as in a skeletal formula. Next one, again, we have to do the skeletal formula and structural formula. So you need to draw your carbon backbone, just a zigzag with 4 points on it. So 1, 2, 3, 4. On the second carbon there, you can see that there's CH3, so we need another carbon. We just draw a line. All right, and to get the molecular formula, it's just carbons and hydrogens. 5 carbons in total. It's an alkane, so that means that whatever number of carbons you have, the number of hydrogens is double that plus 2, which is 12. So I'm just going to put that in there rather than counting all those hydrogens, but you can count them to check that if you like. Molecular formula given to us again for this one. Structural formula. Now, there's not that much you can leave out here. You can leave out the CH3, you can leave out C, and you can leave out the H. So that leaves you with, all right, and then the CH3 that would be there is assumed. You assume because there's an N there, it's a carbon, and then it'll need 3 hydrogens. And the carbon there and the hydrogen are all assumed as well. So because we've got a bend, there's a carbon. And because that carbon will need an extra bond, we assume that there's a hydrogen there as well. Okay, try these before you watch the end of the video, the rest of the video, if you haven't tried them already. All right, so we've got, we can draw in these carbons. I think it's a little bit easier if we actually put the carbons at all of these points. So we have 1, 2, 3, 4, 5 carbons going across. And on the middle carbon, there's another carbon chain coming off the bottom. All right, and then we just need to add our hydrogens. So 3 hydrogens. This one needs 2 hydrogens. Remember, all carbons need 4 bonds in total. This one needs 1 because it's got 3 bonds already. This one's got 2 bonds, so we're going to need to squeeze in 2 hydrogens there. Doesn't really matter about drawing them at any particular angle, as long as it's correct. So it's nice and neat if you can draw it in a T shape there, but I'm trying to squeeze it in this little box I've got. All right, so there you have it. We have an ethyl group, which is a 2 carbon chain, attached to our pentene. So what we've actually got there, count those carbons, it's on the 3rd carbon. So we say that it's 3 ethyl, because there's a 2 carbon group there. Pentene, because there's a 5 carbon chain. Pentane. Ending with ene because it's an alkane. All right, so don't worry about that too much for now, but it is worth knowing, and worth taking note that that's what you would call that molecule. All right, and last but not least, we have a 1, 2, 3, 4, 5, 6 carbon chain, all in a row, 1, 2, 3 to 4. So from the 3rd to the 4th, there's a double bond. And then you just add in your hydrogens. I'm just going to write H3 at either end here, and that lets me know that that's a CH3 at the end. So I would have 3 hydrogens there. Draw in my hydrogens here to make that up to 4. Here we've got a single bond and a double bond, so it just needs 1 more. The same for the carbon beside it. Then this needs 2 more. And there you have it. 1, 2, 3. So it's 6-carbon chain, double bond on the third, so we say that is 3-hexene. 3-hexene. Lastly, we've got 4 carbons here in chain. 1, 2, hold on. 1, 2, 3, 4. Now you could draw it like that, because that's the way it's drawn on in the other picture. You could also draw it like that, because those are going to be the same thing. First carbon and the fourth carbon are the same because molecules can be flipped over. All right, so then the first one, that's 1, 2, 3, 4, 5, becomes 1, 2, 3, 4, 5. So same thing, facing a different direction. And that's it. That's skeletal formula. For each of those, then just count up the carbons and hydrogens. C6H. It's an alkene, so we double the number of H's. Well, another alkene, 4 carbons, so C4H. I hope that makes sense to you. Let me know if you do have any questions.